One speaker today is Professor Quim Segales. He has been studying different families of viruses since the 90s, like Ojeski disease, or of course porcine psychovirus type 2, but as well some of the emerging viruses we are facing nowadays, like coronaviruses. He has co-authored more than 350 peer-reviewed publications, and Professor Segales is currently researcher at CRESA and professor at the University of Barcelona. When we consider PCV2 infection in the field, there are still a lot of pending questions about, for instance, what can we expect from the different diagnostic tools that are available, and how to interpret the result that we can get. Also, a lot of questions about the different circulating genotypes in the field. And then in terms of epidemiology, should we need to think about adaptation of vaccination program, considering these changes that occur in the epidemiology of the virus today in the field? Professor Segales, thanks to his long experience at research level, but always staying very close to the field, will provide today his thoughts. Now, I would like to invite Professor Quim Segales to share his presentation.
Hello, good afternoon. Can you hear me?
Very well, Quim.
Okay, thank you very much, Philippe. Thank you very much to SIVA for the invitation to stay this afternoon with all of you. It's always a pleasure to share some time discussing about different swine pathogens, and certainly Mycoplasma high pneumonia, as depicted before Dominic, and PCV2 are two of most important pathogens, probably together with PRRS virus and some others, but two of the most important pathogens worldwide. So the topic of this afternoon, it's regarding PCV2 vaccination, regarding past, present, and future. I must confess that we can talk quite confidently about the past, quite confidently about the present, and not that confidently about the future, because we are not futurologists at the very end. However, when talking about the past, I would like to remind you, at least the older ones, I would say, no, let's say the most mature veterinarians here in the audience, and if you remember late 90s, early 2000s, the situation with PMWS, with the systemic disease, the PCV2 systemic disease, was quite awful in a number of farms and in a number of places. So from this point of view, it was sometimes a big disaster in the sense that high mortalities and high losses appears in the farms. And for the reason I try to compare the evolution of the disease related to vaccination like a road. So if we compare what the road looks like back to 20 years ago, it was a very bad road in which it was plenty of irregularities, plenty of problems. As you can see the picture with the pigs, and mortality, which was quite important. However, over time, when the vaccines arrived to the market, the things changed a bit. First of all, a number of veterinarians thought that the vaccine was arriving too late because we had to deal with systemic disease for almost 10 years in most of European countries, and the things at least were perceived to be controlled. The reality is that they were not really controlled, but the ones using the vaccine were just few of them. So suddenly this very bad road converted to a nice highway with very few cars, which were the vaccinated farms, in which vaccines worked extremely well. Basically because the efforts by the company selling vaccine at that time was, let's vaccinate those farms dealing with significant problems. Next slide, please, or next click. So soon after the vaccination came there, of course, we realized that it was an excellent tool for controlling the disease. Excuse me, the previous one. So we observed that the PCV2 vaccination showed high efficacy, and here Dr. John Harding, which is in the picture on your right-hand side, indicated that it was able to prevent PCVDs all around the world. So this implied that, especially from 2011, 2012 onwards, almost everybody started using the vaccines. In some countries, they vaccinated almost 100% of the pigs reaching slaughter. In others, it's true that they never reach such high levels, but this implies that our highway, now it's plenty of cars working well because, I mean, most of the farms, if not all, were vaccinated. Next slide. However, what it happened over time, when everybody is using a particular product, is that sometimes there are some losers. As you can see here in the road, there's one particular car which are not really working well. Yeah, but here you have another video in which one car doing very strange things. Those very strange things mean that sometimes we have been ourselves as human beings doing strange things. And for example, quarter doses, mid doses, things like that could be compatible with such a situation, or simply in some farms apparently didn't work. So that would be exemplified with a car on your left-hand side. So the question here that comes along, especially after several years of using PCV2 vaccines, is, do we consider PCV2 vaccines as infallible? Probably vaccines are never infallible. Nowadays, dealing with SARS-CoV-2, most of the society is wondering, even talking about what a sterilizing immunity is, when probably sterilizing immunity is a very nice, let's say, utopic concept, but not the reality. Most of our vaccines are able to protect against clinical signs and disease, but not necessarily against infection. So what about the future? What would be the situation that will accompany with us together with the vaccines? Next click. Well, for the future, you always need a plan. Otherwise, the future will follow the corresponding issue. I just put here a Joker-like picture because, of course, when someone may ask the future to that guy, the right conclusion is probably this guy doesn't have a plan. So the point for us and as veterinarians dealing with farms is we need a plan for the future, in the sense that even we have nowadays a particular plan or vaccination schedule, especially that may work in our farm, the things may vary in the future. So future plans are important, and it's the only way by which future can be more or less predictable. And even so, it could be difficult. Next slide. One particular quote I'm starting with is that all PCV2 vaccines in the market work. However, once said that, it's clear that when you try to see how many works, scientific works, are dealing with comparisons side by side of the different vaccines, you will see that they're very, very minimal in the literature, in the peer-reviewed literature. For example, this is really quite old because it's from 2010, 2011, and this particular work performed in the US compared 3 vaccines in the market at that time. And the conclusion was that the PCV2 vaccines were able to reduce viremia, improve average daily weight gain. However, there were no differences, at least in protective parameters among vaccinated groups. However, they were significant difference compared to the non-vaccinated ones, which, by the way, was expectable because those vaccines, we know they work. Next slide, please. Since those side-by-side studies are very scarce, of course, there are other ways to try to test how efficient are those vaccines and potential comparisons among them. And so far, and even they are slightly old already because they are from 2014 mainly, meta-analysis can provide us evidences of how those vaccines work. And certainly the data that they provide is that those vaccines are very efficient in terms of preventing mortality, in terms of preventing wasting, in terms of ameliorating the average daily weight gain. In most of the cases, no significant difference were observed among the different vaccines that they were tested in those analyses. So globally speaking, those vaccines against PCV2, we must consider they are very good tools in order to control PCV2 infections. Next slide. Therefore, if we are trying to sit down in front of PCV2, let's say like that, which are the real challenges that we may have on 2021? Because we know the past, we know which is the current present situation, but nowadays, what worries us about PCV2? Probably a number of you are not worried at all regarding PCV2 because probably you have PCV2 under control or presumably under control and your farms perform very nicely. However, there are some issues I would like to comment during this talk. First is regarding the diagnosis. I believe we should go back to the basics, but we will discuss about that. Then and this happens in a very few number of farms, but it looks like that sometimes we're vaccinating against PCV2, but the farm experiences or even wasting, which is compatible with PCV2, and eventually diagnosed as PMWS or PCV2 systemic disease. And then, of course, our first feeling is that probably this vaccine is not working. So what should we do in such a situation? And finally, we have been talking about genotypes for a long period of time. So from this point of view, we would like to comment on the different genotypes that are currently known and what can we expect from them. Next slide. Okay, regarding the diagnosis, I believe that we should stick to what we know since many years. Said in another way, there's no change in the diagnostic criteria for the PCV2 systemic disease. And the diagnostic criteria lasts for more than 20 years already. This paper, it's a relatively old paper, but it was a kind of consensus between different researchers working in different countries in Europe that we proposed a her case definition, including, of course, the individual case definition for the systemic disease, which at the very end is very well summarized with a clinical outcome, which was mainly wasting and mortality, with particular lymphoid lesions. And normally what we should see as a pathologist, it should be lymphocyte depletion plus granulomatous inflammation of such lymphoid tissues, and finally, a certain amount of virus, PCV2, in those tissues. If we are able to fulfill those criteria at a herd and individual level, we can diagnose PCV2 systemic disease. And this was already enforced in 1999, is already enforced in 2021. However, next slide. We are relying sometimes on the use of alternative techniques to diagnose the disease. For example, PCR, quantitative PCR, even the use of serology. However, those are excellent monitoring tools, but those monitoring tools are not able to allow a diagnosis of the PCV2 systemic disease. Therefore, the diagnostic criteria for the disease didn't change. However, those new tools allow us to study the epidemiology of the viral infection, including the antibody dynamics. Therefore, those tools are excellent to monitor the infection, eventually vaccination, and why not to help establishing the right moment of vaccination. However, by themselves, do not allow to establish the PCV2 systemic disease. Next slide. So when do you think, or when we think that it's needed to establish a sound laboratory diagnosis? Of course, in those farms with a clinical picture which is still compatible with PCV2 systemic disease. In some other cases where we prefer to rule out that the disease is present, because it might be we see clinical signs of wasting, might be some mortality. We are not completely sure, but we believe it's not the systemic disease. But anyway, to rule out could be interesting. And most importantly nowadays is if our vaccination expectations are not met, or we have a suspicion of vaccination failure, then the PCV2 systemic disease diagnosis is more than welcome. Next slide. Well, it's important as well to talk how it has been evolving the vaccination practices against PCV2 over time. And here in Europe, we mainly started with vaccinating sows, specifically with Circovac, as you perfectly know, at that time, Marial, basically because it was intended for this group of animals. But then rapidly we switched to the piglet because the efficacy vaccination was much more clear when vaccinating the piglet. At the very end, they were the affected animals. Afterwards, piglet and gilts during acclimatization, and why not in the future? And this is happening already in some cases, vaccinating as well the sows. But one thing which is important to remark is with all those actions, we are modifying the epidemiology of the virus. Next slide, please. For example, when you are studying a vaccinated population, it could happen something like that. Here in the blue and red bars, what you see is basically two groups of animals, one with high antibody titers at the time of vaccination at 3 weeks of age, which is represented by the blue line, and the red line representing animals vaccinated with low antibody titers. Look at here, declining of maternal immunity. Those animals were vaccinated at 3 weeks of age, no evidence seroconversion, but look, through the nursery and the growing finishing period, they were no seroconversion. So this means that at the very end of the finishing period, 24 weeks of age, those animals were mostly seronegative. And this means that virus infection might be took place under farm conditions, but the infectious pressure was really, really low. Next slide. Here you have another situation, which is a sow farm in which we tested serologically for antibodies, different sows with different parity numbers. You can see that the parity 0 gilts, they had relatively high antibody values, while from parity 1 to parity 8, we observed wide variability in terms of antibody values measured by ELISA here. At the point that you can see the cutoff of the technique on the purple line, in which we can see seronegative animals together with seropositive animals. So at the very end, this slide is showing us that with PCV2, the theory of the famous theory of subpopulations, mainly applied to birds, also applied to PCV2 and probably to most of the pathogens. This means that we are having animals which are presumably protected versus others which are not. Of course, just measured by antibodies, which of course do not measure full protection, but it's a kind of measure at least. Next slide. So if we are taking into account such a situation, we can almost predict what could happen under field conditions. Look, before existing vaccines, sows were mostly seropositive and usually with high antibody values. So they transfer high levels of maternal-derived immunity to the piglets. However, when the maternal-derived immunity wanes, a proportion of animals may develop PCV2 systemic disease. Of course, PCV2 systemic disease is a multifactorial disease. So we observe the clinical outcome only in those farms in which other risk factors applied. Co-infections, bad management, poor zootechnical measures applied, the host, the genetics of the pig, etc. So that was the scenario pre-vaccination. Next slide. So we started vaccinating. The sows were still quite seropositive with more or less high antibody values. We vaccinated the piglets in certain presence of maternal-derived immunity, and suddenly the disease disappeared. What happened here? First good news, vaccines work even in the presence of maternal-derived antibodies, or at least certain presence of maternal-derived antibodies. So they are able to overcome maternal immunity, and they elicit their own immunity. So at this point, that window that appeared when maternal-derived immunity waned before vaccination now doesn't occur, so we are protecting our animals. Furthermore, we discover the existence of the PCV2 systemic disease. Even those animals that were apparently healthy at that time, they were growing faster with a much better average daily weight gain. Therefore, we controlled the PCV2 systemic disease and we improved our productive parameters. Next slide. Of course, by doing so, what it's happening, and this is the slide I have shown you before in terms of antibody evolution, we are lowering the infectious pressure over time. And if we are lowering such infectious pressure, it happens that probably we generate a number of animals that reach a slaughterhouse which are seronegative. Others might be not. So probably you will generate subpopulations in all cases. And imagine nowadays, or at this point, that you take some of those seronegative animals, you are using them as a gilts, and you introduce directly into your sow herd. Of course, this could be dangerous. Next slide. Because of course, if you introduce such gilts in the sow group, what could happen here is that first, you have subpopulations of serologically naive animals among others which are positive. It's true that the infectious pressure is very low, but you also have animals which are almost not protected. So there's a kind of risk of sow infection. And if there's risk of sow infection, there's risk of early piglet infection as well. So since the amount of maternal-derived immunity transfer is rather low, what could happen here is that those early infections will coincide with the timing of vaccination. So at a given time point, there's a competence between the potential vaccine efficacy and the already established infection at early ages. And this is the main reason why a proportion of pigs, normally is not a huge proportion, but it could happen in certain proportion of pigs, may develop PCV2 systemic disease in spite of being vaccinated. The only point here is that this vaccination is arriving too late for those animals. Why? Because they got early infections because of this change in epidemiology. And this change in epidemiology has been caused by vaccination at the very end. So it looks like contradictory, but it has lots of biological sense. Next slide, please. Of course, in such a scenario, next click, please. In such a scenario in which you see a proportion of animals showing systemic disease in spite of vaccination, the first impression of the farmer and even the veterinarian in most of the cases is the vaccination does not work. And even the argument is, I have always done the same, and by doing the same, the things have changed. It's correct, but by doing the same, at least in epidemiological terms, things change. So one infection is never static, never. So we have to be very conscious on that. And what happened with such a situation? That if there's a proportion of animals that appear sick again, it's very likely that there's a proportion of vaccinated animals that they are not growing as expected, because probably those not able to develop the disease, probably, at least again, a proportion, I insist, do not grow as expected. And what happened? This probably happened in a very low number of farms. So we should not lose our north here, because this means that vaccinated farms displaying clinical signs compatible with the systemic disease represents just the tip of the iceberg. Most of the farms works quite well in general terms. However, it's amazing, and this is very human, but sometimes you only see what works wrong and you do not pay attention to what works well, because it's just expectable and then you don't pay attention. So it's very important when situations like those occur to focus deep investigations, field investigations, what's going on. We are talking about early infections, we are talking about circulation at early times, intrauterine infections, etc. Next slide. Of course, this scenario can be solved at different ways. We may reschedule PCV2 vaccination, and sow and gill vaccination could be a solution. Could be a solution because remember that one of the major problems for those early infections is the lack of immunity of a number of sows. So at the very end, we are having a kind of patchy herd immunity here. Even one solution that should be transitory, probably, it's the early vaccination of piglets. If you are vaccinating at 3 weeks of age, and this doesn't work because infections are too early, might be vaccinating even earlier may be a solution. Even it will be, I insist, a transitory solution. Since you are vaccinating sows, probably it's much better to push the infection to later ages. However, of course, if I'm vaccinating the sow and the gilt, then I may create eventually too high antibody levels in the piglet. So this could be jeopardizing my vaccine efficacy. Of course, in such a scenario, you should consider the need of monitoring PCV2 by PCR, quantitative PCR, or antibodies against the virus. So those are possibilities. And very important as well, be sure that when you are vaccinating against PCV2, you do not have immunomodulatory elements like PRRS or even other infections, or your piglets are not in good health status, because otherwise your vaccine will not work properly. Next slide. In fact, very recently, it was published a review paper on the levels of maternal-derived antibodies, especially in regards to potential interference with piglet vaccination. And one of the things, the issues related with PCV2 infection at early times, so the potential solution, as I told you, it was to reschedule the corresponding vaccination, and it could be in sows or even in piglets. However, what I wanted to comment with that particular paper on let's say maternal-derived antibodies and the potentiality of interfering vaccination of piglets, in fact, they conclude, it was a conclusion of the paper, that the findings suggest that the vaccination of piglets is effective with respect to production parameters and viremia, even in the presence of high maternal-derived antibodies, with an age of 3 weeks at vaccination being most beneficial. So that was the conclusion of that paper. However, when one person reads this kind of paper, one may say, should I not care about maternal-derived antibodies? Well, I would not be that strong. You must remember as well that publications, scientific publications, especially regarding vaccines studies, are published, those that work it. And right now, just to finish up this presentation, to talk a bit about genotypes and what's the potential importance of them. Well, the first question would be, how many of the genotypes do we consider in PCV2? At the very end, it depends on how you classify them. However, there are some classical ones. The classical ones are PCV2A, B, and D. D, it was considered that time ago as a mutant of B, but anyway, it's probably a kind of variant that evolved from B. PCV2A was the most prevalent one before, let's say, the big outbreaks of disease that started by late 90s, early 2000s. B, PCV2B, coincided to be the most significant one at the time of those outbreaks, and PCV2D is nowadays the most frequent one. In fact, we considered what we call a genotype shift from A to B by early 2000s, especially, and around 2010, 2012, a kind of genotype shift from PCV2B to D. I didn't skip C because I don't like it. Basically, PCV2C has been sporadically detected retrospectively as well, and in some parts of the world, but it looks like it's very limited. Next slide. And in general terms, it's considered that there's no clear-cut difference in terms of virulence among genotypes. Let's say that PCV2A, B, and D behave similarly under experimental conditions. However, very recently, it has been proposed that might be in co-infection, they may behave slightly differently. And PCV2D might be slightly more virulent in co-infection with other pathogens. However, there are just very minimal works on that, and this is something that we will have to confirm in the future. Next slide. Well, simply, you can see the genotype shifts that occurred from PCV2A to D around the year 2000, and from PCV2B to D around 2010, 2012. And nowadays, in most parts of the world, PCV2D is the dominating genotype. This implies that the others are still present, however, are not that frequent. This could be comparable in order to make a sound and reasonable comparison with what we know about SARS-CoV-2, in the sense that we are talking about variants, the Delta variant versus the Beta, Alpha, etc. At the very end, the variant with the better fitness with the host is the one that finally dominates. And probably PCV2D is, let's say, the dominating genotype for having better fitness with the host compared to other variants. Next slide. In fact, nowadays we consider 9 genotypes. In fact, several years ago, 3 years ago, we proposed together with Giovanni Franzo the existence of 8 different genotypes, in which A, B, and D are the most important in terms of frequency. And soon afterwards, an American group found what we was called the PCV2I. So 9 genotypes are currently recognized nowadays with PCV2. Next slide. But anyway, we must confess that the number of genotypes depends directly on the genotyping criteria. So this means that it's very likely that new genotypes will appear in the future. So this shouldn't be surprising. Next slide. And this is the very final slide, because the problem or the existence of genotypes, it should not be a problem by definition. However, the point here is there any impact of the genotype infection that may change the vaccine efficacy that we see under field conditions? That's a relevant question. So far, we consider that there's still one single serotype with PCV2. This means that there's cross-protection between PCV2A, B, and D. Therefore, even vaccines based on PCV2A can protect against PCV2D, for example. Of course, it's a kind of full protection as if it would be exactly the same genotype. Probably not. However, in order to prevent clinical signs and to improve average daily weight gain, this is more than sufficient. Again, studies would be needed to compare side by side different vaccines with different genotypes in order to see what's going on. However, this would be an extremely expensive study probably, but it would be very worthy in order to assess the difference in genotype in regards to vaccine efficacy. And I believe that that was the very last slide. Next one. Oh, yes, that's correct. There are some the take-home messages that I will summarize very rapidly. Certainly, if you have suspicion of PCV2 systemic disease, you should confirm or rule out. So it's not the same to diagnose the disease rather than to monitor the infection. So you must take this into account. If you have a confirmation of the systemic disease in a vaccinated farm, let's try to be sure which is the triggering phenomenon. Might be you have a problem with vaccine application. Might be there's interference with maternal-derived antibodies or immunity. Might be you have early infections. You must investigate what's going on. And of course, try to counteract the cause in case you find the right way. Remember that vaccines work. So something should be arranged at the epidemiological level in order to keep them working. Next slide. Importantly, PCV2 systemic disease, as I told you, is still a multifactorial disease, in spite that we have excellent vaccines. So the lack of expression of clinical disease does not mean that we are getting the best. Remember that the subclinical infection is a reality, and it was discovered because of PCV2 vaccination. But regarding what's the plan for the future, we have been the joker like before. So what was the plan? First of all, we have to have in mind the concept of infection, the chain of infection. And it's important to know who is involved in the maintenance of the infection. And also there's another concept which is very important in vaccinology, which is the continuous protection. You should protect all characters participating in the maintenance of infection. We have seen that the piglet, of course, play a role, but the sow play a role, and of course the gill. So, and this is a kind of forecasting that we'll see how it evolves, but my forecasting for PCV2 vaccination is that we will end up vaccinating sows, the breeding stock, as well as piglets and gills, which is what is happening nowadays mostly. So we should go for the whole herd immunity. And I'm pretty sure that this is paid back. Of course, cost-benefit studies will have to be performed in order to demonstrate such effect. And with that, I'm finished presentation. Thank you very much.
Thanks a lot, Professor Segales. And for sure, yeah, the practical example that you have presented today will stimulate a lot of interest in the audience. You have clearly illustrated that in virology, the environment and the epidemiology are constantly evolving. Nevertheless, you confirm that the good protection can be offered by PCV2 vaccination, and that it was very important to understand better what we have to consider in terms of herd immune status or the presence of maternally derived antibodies, for instance, to get the best out of the vaccination investment.